It's the least I can do. Okay? Then your Aristotle, wow, Aristotle is like half the class, right? 1, 2, 3, no, 3, 4, you, 5, no, you. Huh? Oh, I'm tone deaf. Okay. Yeah. See, I can't hear. Huh? I can buy. Okay. Miss Jen called me to buy a lot of flowers. Okay. Oh no, this recording. Okay, so I start. Okay, so topic 5. Okay, it's a very short chapter. Basically, after you have learned differentiation techniques, if you still remember chain rule, product rule, quotient rule, it will still apply here. Okay, what is different is you are looking at the derivative of trigo, exponential, as well as log functions. Okay, yes. What are you showing me? Huh? Zoom. Oh, Zoom. Do I see you? Okay, can. Okay, you're looking at the derivative of. So I'm going to skip the first part. The first part is on proof. Okay, I'm going to skip the first part. I'll come back to it another time because I want you all to have some. This part is a little nerdy. I mean, it's a little. Yeah, I'll get back to this. Okay, the proof part is first principle, not really tested. It's more for knowledge. But rather, I'll come straight to page number 4. Can you follow with me to page 4? Sean never bring notes. Okay. Next lesson, try to bring that one. Very easy one. The derivative, yes. Sorry? Oh, okay. Can you? Okay. The derivative of sine x is cosine x. The derivative of cosine is negative sine. The derivative of tangent is secant squared. Okay, so I just give an example. Okay, if you take a look at sine, okay, the proof is by first principles. So if you ask me, Mr. Tan, why is it like that? I can't answer you. So I ask you, okay, look at the one in red. What does it look? What kind of graph does it? Oh my God. What kind of graph does it look like? There's some hang in my screen. So sorry. Cosine. Can you see? Can you see the cosine graph? So now you look at sine versus cosine. You can see that sine graph, cosine graph. This is one of the way to show you that the derivative of sine is cosine. Okay? And the actual proof is by first principle. So if like today you ask me certain why is it I can't really answer you, but I'll tell you the proof is by first principle. Okay? Which I will not go through. Okay? Not today. Now you look at cosine graph. Now if I show you the derivative of cosine, what do you see? Yes. What do you see? Can you see it's negative sine x? It's like sine x but it's reflected on the x-axis. Okay? Cannot. It's like sine x but reflected about the x-axis. Okay? So sine and cosine, you're not tested on how to prove it. You are just tested on how to use. That's all. I mean, if they show you the derivative of sine, you must know that's cosine. Cosine is negative sine. Okay. Now for tangent, so now you look at let's look at question 1.1. Sine and cosine I can't show you, fortunately, not at this moment. But tangent I can show you. Okay, so how? Let me show you. Question 1.1. Right tangent and sine over cosine. Right tangent and sine over cosine. Differentiate tangent, right? Means this is our graph. We are finding the gradient of this graph. Let me write it as sine over cosine. So okay, you all see a function. see a quotient. So if I see a quotient, what do I see? Quotient rule. Right on. Now this is my u. My u is sine x. What is my u prime? Cosine, cosine x. If my v is cosine, what is my v prime? Negative sine. Okay, so now we'll try with quotient rule. Try to apply quotient rule to this. You should be able to get the square. I'll just give it a try. It's quite easy, quite easy. Yeah. YEA, you will not get derivative formula. You will get formulas like for trigo. Oh, you get formulas for trigo. Double angle, addition, Pythagorean. That's about it. Sine rule, cosine rule. This no, they will not give. They will not. You have to memorize it. It's our formula. No need. You can just use it. No need to put it. Yeah. Different derivative of for trigo for differentiation calculus and integration. Always do in gradient. We always do in gradient. We don't do in degree. Okay, because everything is in terms of pi. Yeah, just a standardized output. Okay, ma? Know how to do? Anyone stuck? Need me to show you? Either done. Okay, go to the next one. Try the left hand side. It seems like you all are doing well. Wow, very good. Okay, I slowly show you all. Okay. Where am I? This one. Okay. This one, ignore first. You all haven't learned chain rule for trigo yet. I'll go through in a while. This is question 1.1. This is question 1.1. Okay, you can see that here I'm applying the quotient rule. I'm applying the quotient rule. Okay, this is my u. Then this is like u prime b minus b prime u. This is b squared. Okay, I'm applying quotient rule. Okay, after which I look at my sine square and cos square. Sine square, cos square equals to 1. Okay. Yeah. Lawyer. Oh yeah. Okay. Can so you get 1 over cos square. 1 over cos square is secant square. Okay. Boleh? Can Okay. Okay, then I go to question. How do I do the first part? Which one again? The first cos x. Okay, derivative of cosine equals to negative sign. You skip first. You skip first. This one you skip first. So these two results you take first. This you can prove. This one you need first principle. Okay. I will come back to this question later on. Because yeah, I think the question flow not so good. Different chain rule for trigo. Xavier, later I need to show you. So later you akan datang first. This is the second one. Okay, so now I go to question 1.2. Okay. Derivative of cosecant is minus cosecant cotangent. Derivative of secant is secant tangent. Derivative of cotangent is minus cosecant square. It's all provable. Okay, all provable. See what? Okay, so like it's you can prove it. You can prove it. Can I? So what do I do? Very simple. Write this again as cosine. Write it in terms of 1 over sine. Write this in terms of 1 over cosine. Write this in terms of cosine over sine. Then guys, you all try to prove using quotient rule. You all should be able to get it. Okay? And so it's just a matter of your starting point. You just start with the quotient rule you should be able to get. If you never bring your notes, it's okay. You can log into the Zoom. Are you okay? You sit up. You sit up. I saw you. Ah, you can change to secant square. No need. No need. No need. Sine and cosine is just a strategy. Like I simplify so that I can work on it. But final answer don't need to change to sine and cosine. So far, yeah. Once you okay, slowly, slowly. This is just proving. You should yeah. If you have problem proving, you let me know. So as you are doing, yeah, thing that you should know. Okay. Formula A level H2 math. Okay, it's not in O level math. So your counterparts in other secondary schools, they may not have learned it. But for you, it's for you to know now. Okay, you will be tested on this. It's part of your syllabus. Okay, it's part of it. Need to memorize. Need to memorize. Okay, can all these three need to memorize. Can why you so tired? See a lot of you It's because of the rush. Or is it because of Arista? It's because you have CCA this morning. What's the Once you're done, you can go to 1.3. Sun do already. 1.3, I read the answer. 1.3, 1.4 answers on the board. 1.5. Powerful as well. If you can get up to 1.5, it's fantastic. For me to pass off. Okay, 1.2, okay? Yeah. Yeah. Okay. Okay. Let me slowly show you the answer. This is 1.3. Okay. Is anyone at 1.4? Wait, 1.4. Okay, so now I will go through 1.4. 1.4. Okay. So 1.3, I should be okay. Just remember, product quotient rule still applies to all your derivatives. Whenever you do differentiation next time, till you graduate, some of you might engineering, you might go to computer science, you might go to economics, you might go to finance. Whatever, most of your majors, if there's math inside, you will be learning calculus. Okay, also you'll be learning differentiation. So now I go to chain rule. Yeah, for those who are 1.4, you might want to pay close attention. Hey, handsome. So sine, let's say for example, if I give you a sine of a function, okay, you all remember the idea of chain rule? Yes, inner layer, outer layer. You like peeling an onion, you peel from outer to inner. So if the function looks like that, can I say that this is the outer layer, this is an inner layer? Can you all see? Yeah. So layer number one, you can see, layer number one, layer one is like sine. Layer two is like fx. Okay, so what is my derivative? So here, if I'm doing my derivative, right, all I need to do, differentiate layer one, multiply by differentiate layer two. Okay, let me just take away the L, not very confusing. Okay, I differentiate layer one and layer two. So if I differentiate sine of whatever, it gives me cosine. Since you stay away, okay, it will give me cosine. Cosine, right? If I differentiate fx, I will get f prime. I'll get f prime. Okay, so it's f prime.
Wow.
Who is it?
Oh.
Who is it?
Oh, sorry.
It's Dora. No, it's Kang Yu. No, it's not Kang Yu. Kang Yu never. It's not K1. K1 didn't even join audio. It was okay. Okay. So it's f prime cosine fx. Clear? Here, f prime cosine fx, Okay. So now I ask you, quickly, Okay, let me ask Sean. Because I saw you paying attention. Differentiate sine of 7x. Very good. Who was paying attention? Differentiate tangent of differentiate tangent 3x. Huh? Can possible? Differentiate from outside to inside. It's okay when you're ready. 3 secant square 3x, correct. Okay. Aiden, differentiate cosine 2x. You don't know it. Okay. Micah, Tatiana, Ballerino. Okay, so differentiate cosine 2x. Differentiate cosine 2x. Yes, you try to give an answer that's well. Correct. Probably differentiate tangent 3x. Three. Very good. Okay. Can Salihan, cosine 7x, differentiate cosine 7x. Okay. Okay. Sorry. Okay, so this is my second time teaching chain rule, right? If you are at question 1.4 now, anyone who is at question 1.4 now, who is interested to listen? Please tune in, right? So this is my second time going through sine or trigo, there are chain rule. So derivative of trigo function chain rule is very confusing. I'm going to go through the first layer first. First layer is sine. Okay, inside fx. Remember the idea behind chain rule is we go layer by layer. What's the first layer? Sine. Can you see the green what color is the first layer? Now what's the second layer? Fx. So you differentiate outer layer, differentiate inner layer. Then you multiply together. Okay, differentiate outer layer, sine of something is cosine. Differentiate inner layer is f prime. Then you multiply together. So far, okay? Salihan, try again. Differentiate sine 2x. Never mind, are you ready? 2 cosine? Very good. push. Okay. Oh, okay. Okay. So I hope you are successful for 1.4. Okay. 1.5, anyone at 1.5. So if you are at 1.5, how to do, right? Okay, so now I go through the second layer. Just now got one layer, right? Now got two layers. Today is like many layers. Second layer of trigo, what does it look like? Sometimes, okay, you all will see this, right? Example, sine square 7x. So they also Shivani look at this. Wow, this one so many layers. So how I sell you is I sell you in this way. Okay, can I sell it? You're not there? Shut up, Isabel. Okay, so can I say this is the first layer, pink color? Can I say this is the second layer? That's not all. Still got more. Very fun one. Can I say this is the third layer? So you put the power to outside. You put the power to, even though okay, because for trigo, right? For trigo, right? Because when we put 7 here, this really means that sine x, the entire thing power 7. But this is not the same as sine x power 7. Different, or not the same. Okay, so just think. So here, differentiate layer 1. The layer 1 is something power 2. Layer 2 is sine bracket. Layer 3 is 7x. Yeah. Can. You go to North Korea. Let me show you a third layer. Yeah. Let me show you something like this. 7x also means sine power, yes. Sine power x 7x plus 3 power 9. And then the whole thing. So this is sine 7x plus 9. 7x plus 3 to the power of 9 to the power of 5. Let me change this up. Okay. So guys, look at this. This is so beautiful, right? Just look at this. Okay. Okay. Look at this. Yeah. Let's say I change this to brown color. Can you see got 3 layers, 4 layers? Blue, brown, red, black. Yeah. The first one, who's the most outer one? There you go. The most outer layer is the can you see the most outer layer is power 5. Second layer is sine. Correct? Third layer is 7x plus 8. Third layer is power 9. Shut up, Michael. Okay. Was it even Michael? No, that was Isabella. Sorry. Fourth layer is 7x plus 3. This is the most difficult one. This is the most difficult one. Yeah. So maximum 4 layer. Can I? Maximum. I will think maximum 4 layer. Have you solved with Have I solved with more? Not that I recall. Okay, yeah. Can I? So this is the try your best to pay attention, because if you try to understand this on your own, it may take you more time. Okay, so I know you are tired, but let's do your best. Let's do your best. Okay? Can I? Then I go to copy and pause a while. The answers are on the board. I'll go around to help you. Yeah? 1.5A. 1.5A. A, B, C, D, E, F. 1.5A. So if you look at 1.5A, it's a very beautiful question. Okay. 1.5A. Yes, it's chain rule. Can I demonstrate? But I got no chain. I need to find someone with a chain. Okay. Sanana got chain. Necklace. Chain rule. Okay, so this one, this is the outer layer. This is the inner layer. You see it, Sean? Can outer is the power 2. Power 2. Differentiate the outer layer. What do you get? 2 bracket power 1, right? Differentiate sine x, the inside layer. Differentiate sine x, I get cos x. Okay, huh? Can I? Okay, you all look very tired. I'm going to pause for a while. Wait. Oh. The recording is going to resume. Please listen to me for the last 2 minutes. Okay, so I think so far you are okay, doing well. So I'll just repeat again that Trigo, one thing to look out for today is the chain rule. The chain rule can be very confusing. Okay, let's say for example, if I look at this, right, super confusing, right? Write it cosecant. I even use like highlighters, just to make it obvious. Like for example, you can see how you're using different colors, right? This entire thing to the power of 2, right? Just use different highlighters. Make sure you separate the layers carefully. Okay, just like tidying your cupboard. Then you differentiate layer by layer. Here so far? Can then take note, inverse and reciprocal are different. Sine inverse is not the same as 1 over sine. Similarly, when you put a power, make sure are you doing so there's a difference between sine of x squared, and there's a difference not the same as sine square x. Okay, it's precisely because mathematicians want to avoid confusing these two. So when it's an entire power, this, right? When it's something like this, right? They put the square over here instead of here. Okay, okay. So make sure you all are here. Whether it's sine of x squared or sine x and whole thing square. Okay, then what else? Okay, this weekend, please do your not waving. Okay, so this weekend, please do your practice set 1, 2, 3 for modulus. Assignment modulus, you all got already? Okay, you also can do. So start to do. Practice set 3, modulus, practice set 3. You all draw graph, it will take you quite a while. So slowly. Cater about 1 hour plus. Practice set 1 and 2, I think 45 minutes. Those who haven't done, 5 minutes can finish. Most of you are done already. Practice set 2 take you half an hour. Practice set 3 will take you a long time, so cater some time for you. Okay? That's all. Enjoy your long weekend. Thank you, class. Thank you, class.